Hey guys, welcome to 9.1 example 3. Find these examples to be kind of easy to do, but very interesting, and understanding example 3 really helps you develop a stronger understanding of permutations and combinations, which we're going to be getting into very soon. So example 3, it says count the number of 9-letter words. Count the number of different 9-letter words. Don't worry about whether they're in the dictionary. That can be formed using the letters in each word. So in A, dragonfly, there are 9 letters. And so imagining you making a tree branch, right? It would be the first letter could be D or R or A or G all the way to Y. So you can basically have 9 letters to pick from. The second letter, you'd have 8 letters to pick from, all the way down to 1 letter to pick from. So at the end of the day, it would just be 9 factorial. So if you did 9 factorial, let's just throw that in our calculator. 9, let's see, math probability 4, and that'd be your answer. 3, 6, 2. So 362,880 different arrangements of the letters from dragonfly. And dragonfly is obviously one of the possibilities, but you can have ragonfly D, right? All the different possibilities. Now let's get to B. Now B's where it's more interesting because you have the word butterfly, but what you want to think about in this case is that it would be starting with 9 factorial because there are indeed 9 letters. However, there is an issue. Butterfly itself is one of the arrangements of these letters. So it counts for 1, but there are 2 T's. Well, if I wrote it like this, I wrote those subscripts with the 1 and the 2 and the 2 and the 1 to show you that, there's 2 T's. So if you switch to 2 T's, technically that's another arrangement. However, the 2 words butterfly, butterfly are not distinguishable permutations. And the way you want to think about the math is that there are other words. You can say there's fly butter, right? Or tubber fly, or, there's a bunch of other arrangements of the letters from the word butterfly. In fact, we know that there are indeed 9 factorial arrangements of those, or 362,880. But in those arrangements, there's a bunch of them where you end up doubling, you end up with a duplicate because the T's got switched. So again, in the base example, butterfly, I already see there's 2 of them because the T's got switched. Well, what do I do to fix that? Well, if there's 2 of them, well, I probably should take the number I have and divide it by 2, right? Because, I see that I'm counting 2, but I really should only count 1 of them, so there should be half. And this is true of all the other arrangements of the other letters with the double T's being switched. So at the end of the day, I'm going to divide by 2. But just to make it clear as to how the formula actually over here works, you see that? Why do they have factorials? Well, if you think about it, T and T got switched. So really, we end up with increasing the number by a factor of however many number of letters that are repeated. So if you think about it, in the first spot, T, I want a T there and I want a T there. How many T's can I pick from in that first spot? 2. And then how many T's can I put in that second spot? 1 then, because I have 1 left. That means I have 2 times 1 different ways to arrange these letter T's, these 2 T's. And that's why it's 2 factorial. Now, mathematically, we don't need the factorial because 2 factorial is 2. But at the end of the day, this is the logic. We're trying to figure out the number of different ways we could rearrange those repeat letters. because that's the factor in which we are increasing the number of permutations by, and we don't want those duplicates. So we're going to remove them by dividing out that number of arrangements. And let's do that on our calculator. I'm going to get a fraction going there. I'm going to hit alpha F1, get my fraction, 9 math 4, go down to my denominator, and then divide by 2. I know you could just leave a 2 there, but just to, could be consistent. So you'd end up with 181,440. Okay, let's go to C now. Same thing. Bumblebee could be bee bumble. It could be, umble, beeb, right? However you want to rearrange these letters. There are tons of them, right? If you try to draw a tree diagram with it, it'd be nearly, well, in practice, impossible without, a computer or something do it for you. Now, bumblebee, again, 9-letter word, so we definitely know that it has 9 factorial on the numerator, but again, whoops. We know bumblebee is one of the arrangements, so I'm going to start with that one. But if you take a look, there's 3 B's and 3 E's. So let's just focus on one of them for now. Right? How many different ways can I rearrange those 3 B's? Well, in the first one, there's 3 B's to choose from. In the second spot where the B is, there's 2 more B's to choose from, and then 1 more B to choose from. The letter B, not a literal buzzing bee. So that means there's 6 different ways to rearrange those 3 B's in the arrangement of bumblebee. And that means that in all the other arrangements, there are 6 different duplicate, I shouldn't even say different, but there are 6 duplicates in all the other arrangements as well, which means we would want to do 9 factorial divided by 3 factorial, right? But that's not it. We also have the 3 E's, and the 3 E's can also be arranged 3 times 2 times 1 ways or 6 different ways. But again, they're not distinguishable permutations. And so that's also going to be divide by 3 factorial. So let's do that on the calculator. 9. And we end up with 10,080. All right. So there's 10,080 arrangements. And if you multiply this by, right, because 3 factorial is 6 and 6, that would be, we divided by 36. So if we only did 9 factorial, which was up here, this is just, this divided by 36 would be this, because 3 factorial is basically 6 times 6 is 36. We don't need to do these without we're going to do these with a calculator, obviously, because these numbers are very large, but just to show it, because at some point it is good to see it. If I have 9 factorial, if the numbers were small enough, you could do these calculations by hand. If it wasn't a distance learning situation, you probably would have some questions that you would have to do by hand on your test or quiz. But that's not the case, but still, you should still see it. So you can see the 3 and the 2 and the 1 cancel, and then obviously 3 and 2 will cancel with the 6. So at the end of the day, you're really left with 9 times 8 times 7 times 5 times 4. And again, understanding sort of, again, why we're dividing out the factorials, because those are the number of ways you can rearrange the same letter, these repeat letters. hopefully that makes sense to you guys. So if you have any questions, let me know. This is a really, I actually think it's pretty cool to see how these numbers work with this little formula here. And if you understand this, the combination permutations coming up will probably be easier to understand and more intuitive. All right, take care, guys. I'll see you in the next question.